Hello. So these notes are on unit analysis. We'll be working on this for 2 days, Thursday and Friday. This is generally this is the last topic of Unit 0, and this is generally I would say the topic that students mainly struggle on, if they struggle on any of the six. And this is something where it's definitely okay to be confused. We might not understand it the first time. It's going to take some practice, right? I think for the previous topics that we worked on so far, you probably understand it just from other classes that you've already worked on. But this is generally a topic that is exclusive to ninth grade mathematics. But we'll still generally see things that are familiar, but um, it'll take some time. All right. Anyways, go to update your table of contents 0.6. Let's go and get to unit analysis. So some key vocabulary terms. We have unit of measure. Unit generally means one, so a measurement that there is one of. Okay, so like 1 mile, 1 ton, 1 day, things like that. Ratio. So ratio. These next three are familiar from middle school mathematics. The amounts of one quantity compared to another quantity. There's varying ways that we can write a ratio, where we can write a ratio as a fraction. So let's say like let's say 3 tablespoons of sugar to 2 tablespoons of water. Okay, we could write it like that. We could write it like 3:2, or we can actually just write the word 2 in between, 3 to 2. A rate. So this is using ratio. It's a ratio of two quantities in units. So an example here, I think one that's we're mainly familiar with, let's say, is like miles per hour. Right. So that is 2 units there. Miles, a measurement of distance. An hour, a measurement of time. What else could we say? I guess we could also use other things. We could use kilometers per hour. Just in terms of, right, we could have cost per pound. Let's say we're at the grocery store, we're buying lemons. Well, generally lemons are per item, but let's say, what's per pound? It could be like peppers, right? What's the cost per pound of whatever you're getting? All right, so those are examples of that. We have rate, now unit rate, a rate with a denominator of 1. So an example would be, let's use miles per hour. We could say 60 miles, the abbreviation is MI, per 1 hour. Or we talked about unit is measurement that there is one of. So this is an example. So let's say 100 miles per 2 hours. That is a rate, but that is not a unit rate. If you simplified 100 miles per 2 hours, you could get, right, 50 miles per 1 hour. So this has got to be where the denominator is 1. All right. Before we get to this next part, I actually want to get to some fraction practice. Where can we write this? And there's some open space over here. So I'm just going to give us some things here. Let's say 6/2 times, I'm just going to give us some, just two fractions that we're multiplying. Let's say 4/3. Okay. A way that we can simplify this is you can multiply across, right? 6 times 4 is 24, and 2 times 3 is 6. We can simplify this to be 4. Okay, so that process is multiply and then simplify that fraction. You could go through that method. We are going to get to some fractions where there's going to be a lot of numbers, and maybe it's a little bit more useful to simplify and then multiply. So an example here, I'm going to write down the same fraction. Right, we can do this in a couple of different ways. Let's see, Don't draw this yet, but let's say I were to simplify 6 and 2, right? There's a number that can go into both 6 and 2, right? That are factors of 6 and 2. It's 2, right? 2 can go into 2 once, and 2 can go into 6 3 times. Right, so we can simplify vertically, but we can also simplify diagonally as well. Let's say 6 and 3. Right, 3 is a factor of both those numbers. 3 can go into 3 once, and 3 can go into 6 twice. We simplify that way. We could also simplify diagonally again this way as well. 2 is a factor of both these numbers. 2 is a factor of, right, 2 can go into 2 once, and 2 can go into 4 twice. And if you multiply this across, right, we're multiplying 2 times 2 now. This is 4. And 1 times 1, which is 1. And that gives something slightly simpler to multiply. Really, it's really down to your preference, what you feel like doing. But these are me just kind of giving you two different options there if you're not familiar with. All right, before we get to our examples, here we have varying measurements. We have measurements of length, right? So distance, we have measurements of mass. So pretty much dealing with, right, we have weight there. We have volume and capacity, right? Maybe think about like filling up containers or liquids, unit of time. But one thing I do want to point your attention to is these bolded items here. Now, these bolded items are dealing with two different systems. For the most part, in the US, we deal with so we're just going to put US, we deal with the customary system. Now, hopefully you're familiar with this, maybe in your previous math classes or your science classes, most likely your science class, right? So we use predominantly, right, feet, inches, yards. Not too many other places around the world uses that, but these bolded items can convert from customary to the other, which is metric. And metric deals with like base 10. So let's say I don't have too much here, but let's say centimeters. Right, there's 100 centimeters in a meter. There's 10 millimeters in a centimeter. There's 1,000 meters in a kilometer, right? So those things are kind of nice because they're either like 10 or 100, depending. But if we need to convert from one to the other, which we will have to do at some point, we'll have to use that. And we can see like the numbers aren't so nice, right? We get this approximation. So the other topics that we worked on, we haven't been allowed to use calculators. This one we will be allowed to use calculators, so you're welcome to use calculators on your Chromebook. All right. So what the whole idea of this topic is that you're converting from one unit to another. Now, there's certain things that we probably know offhand that we can convert, meaning like how many, inches are in 1 foot, right? That's 12, right? That's probably just like a fact that you know. How many minutes are in an hour, right? So those are things that you probably don't have to think too much about. But we're going to get to some where the conversions aren't probably that simple, and there is some math involved for us to get to, that answer or unit that we want. All right, so how do we do this? We're going to set up a series of fractions. Okay, the first thing that we're going to do is you're going to set up a fraction with the given information. We'll say given info. Okay. Now, what that looks like, we have a fraction here. Whatever you're given, unless it's a rate, you're going to put the given on it's going to be this first fraction that we set up, and this is going to be over 1, right? Anything divided by 1 is just that thing, right? Now, these other fractions that we set up, we're going to set up another fraction. We're going to set up equivalent fractions. So equivalent fractions like this, let's say, and we're going to see this more concretely in the examples that we have. Let's say you're going to have something equivalent to the given, and then above it, it's going to sound somewhat unusual, but we're going to say it's equal to given. Okay. Now, the reason that we do this is because if you have something, let's say, you don't have to write this next part, but let's say you have 6 divided by 6, right? So let's say you're given 6, and you have something equal to that given, which is also 6. 6 divided by 6 is 1. If you have, I don't know, let's say 14 divided by 14, right? These are equivalent fractions, that's also going to be equal to 1. So what's really happening is these fractions that we set up, go and write this though, just put a 1 there. Let's erase this. Is that it'll be equal to the same thing here. And then step 3, this is where the arithmetic comes in. You're going to multiply / simplify any fraction. Doesn't have to be in that order. We talked about her earlier. It could be switched. Now, these were just words, so let's get to some examples. How many inches are in 3 feet? Now, you can think about that. Hopefully we know the answer to that. 3 feet is 1 yard, so think about that yardstick. Maybe you're holding it. It's about waist level from the ground. So how do we set this up? What I would recommend that you do is you underline what you're given and you circle what you want. What we want is in terms of inches here. Okay. So what we have here, we're going to put our given, which is 3, and we'll abbreviate typically. We'll put 3 feet. Since this isn't like 3 feet per one, I don't know, hour, minute, whatever, we're just going to put this over 1. Okay. Nothing's happened yet. We did step 1. Now we're going to set up this fraction with what it's equal to. Is there a conversion from feet to inches? If we look at the information we do have some information. We have feet to inches here, or specifically 1 foot to 3 inches. Now, 1 foot is a ruler. Sorry, did I say 3 inches? 12 inches. 1 foot is a ruler. 12 inches also equals the same distance as a ruler as well. So we're going to convert here from feet to inches. Sometimes it just helps me to write out the units or the path to get from one unit to my desired unit. I'm going to write 1 foot somewhere in this fraction and 12 inches somewhere in this fraction. I'm going to set up, though, since I have my given on the top, the numerator of my first fraction, I'm going to set up feet or foot in the denominator of my second fraction. The reason that we do that, so I'm going to put 1 foot is equal to 12 inches. The reason I'm doing that there is because we talked about how we can cancel out values, but we can also cancel out units. So let's simplify this. So now we did step 1, step 2, now we're on to step 3. So we're going to cancel some things out, multiply some things out. Let's talk about this. Okay. We're going to look at our units. Just like how we had 6 divided by 6, that's 1. 14 divided by 14, that's also 1. We have foot divided by foot. That's also 1. These lines that I'm actually crossing off, those lines just represent ones. And ones aren't really super important. So what else can we do here? So on our denominator, we have a 1, we have another 1. On our numerator, we have a 3, and we have a 12 inches. So we're going to multiply this out. Right, 1 times 1 is just 1. There's no units on the denominator, so I'm not going to write any units here. That's just going to be free and clear. All right, let's use our numbers here. 3 and 12. Right, 3 times 12 is 36. Do we have any units? Yep, I have some units that did survive. I'm going to put 36 inches. Now, 36 inches or just anything divided by 1 is just that anything. So this is our final answer, 36 inches. So looking back at the question, how many inches are in 3 feet? Yeah, it's 36. Hopefully we just knew that offhand. If not, perfectly fine. Right, there are 12 inches in 1 foot. And if I have 3 feet, really you could just think about multiplying 3 times 12 to get that 36. This kind of just a basic conversion there, not too complex. But yeah, we'll leave it at that. Okay. All right, let's move on to example 2. Now, example 2, we're dealing with the metric system. And the metric system, we actually don't have too much information here, so that's my fault I didn't include that. But hopefully we have some understanding of the metric system. So we have really just 2 more examples. So how many millimeters are in 4 meters? So 4 meters, so this is still dealing with distance. A 1 meter is somewhat close to a yardstick. It's slightly bigger than a yardstick. It's really the height from like the ground to like a doorknob on like any like kind of traditional door. So think of that as 1 meter. So 4 of those, you can conceptualize that. We're going to convert that in terms of millimeters. Now, this you don't have to draw. I'm just going to draw a yardstick here. Okay, this is a bad yardstick. This is 1 meter. Some things that we need to know with this meter is that there is, not that I'm going to do a good job here, there is a number of centimeters here. There is 100 centimeters in a yardstick. Whoops, 100. Now, what kind of cues me in on that is because cent, right? Cent, that prefix, that means 100, right? 100 cents in a dollar. Centuries is 100 years. So that is somewhat important there. Now, what we have here is in terms of millimeters. Okay. Millimeter, if I zoom in here, so if this right here is 1 centimeter, a centimeter, you want to think of that as it's the, I wish I had I could show you in class. Let's think of this in terms of I think it's a penny. This is 1 cent. It's the width of 1 cent. Okay, but so this is 1 cent right here. But a millimeter, there's 10 millimeters. I'm not gonna be able to fit in here. But there's 10 millimeters in 1 centimeter. 10 millimeters right there. The way you want to think about that, if I were to take this penny and kind of rotate it so it's lying flat, that is 1 millimeter, 1 mm. Anyways, we're asking how many of the depth of that penny is for right, 4 meters. Okay. Anyways, before we start this, like I said, it's kind of important that we determine the path. We're going to start with meters. And then from there, we're going to go to centimeters. And then from there, we're going to go to millimeters. All right, so we're going to have more than just 2 separate fractions here. We're going to start with what we're given, 4 meters. So 4m. This is not a rate, so I'm going to put this over 1. Okay, next thing. We're now going to set this up from meters to centimeters. Now, this drawing that we just said is that there's 100 centimeters for every 1 meter. Okay, so 1 meter, am I going to put that on the top or the bottom? I'm going to put that on the bottom here. And the reason is because I want to cancel out that unit with what's in the numerator of that first fraction. Because when we multiply this out, we only want our desired unit of millimeters. Okay, we said 100 centimeters are in 1 meter. Okay, and now we're going to go from centimeters to millimeters here. All right, this drawing here, we said that there is 10 millimeters in every 1 centimeter. Okay. Okay. So 10 millimeters in 1 centimeter. Let's start with that 1 centimeter. Since I know it's right here, I'm going to put 1 centimeter down here. This is the width of a penny versus 1 millimeter is the depth, if we were to lay it down, of that penny. Okay. Now what happens here? These are the 3 different units that we set up fractions for. Okay. Now let's move on to step 3. We're going to multiply / simplify. I'm going to cross out any units that we're able to cross out. Meters cancel out, right? They're just equal to 1, so we draw those lines to represent ones. Centimeters also cancel out. So we can see the only unit I have left is millimeters. Okay. So let's go and put equal to. All right, I'm just going to go ahead and put millimeters. If you look in the denominator, there's actually nothing that we really do here. 1 times 1 times 1 is just 1. There's no unit in the denominator because everything that we had here and here canceled out. But we can do this mental math here where we have 4 times 100 times, oh, whoops, I forgot about that. I messed up. Let's put 10. There was 10 millimeters in every 1 centimeter. All right, let's get back to it. Okay, what is 100 times 10? When you multiply numbers that end in 0, you could just really put that many zeros at the end of the number. So I see that there's 1, 2, 3 zeros. So you could put, and this is really just 1,000. 1,000 is a 1 with 3 zeros. So this right here, 1,000. So what's 1,000 times 4 here? That is 4,000. All right. So there is 4,000 millimeters in 4 meters, right? The thing that we said that's about the doorknob of a door. You know, I'll put this in black. And it's all divided by 1. We don't need it like that. We can just write it as its own value. In this case, in terms of distance, 4,000 millimeters. Okay. Let's go to the last example. Last example is we're looking at kilometers. Now it says kilometers per hour to miles per hour. This is a rate, but since I'm not in class, I kind of don't want to give you a rate. I'm just going to give you just 1 unit. So let's cross out the hours here. We're just going to convert, a kilometer is how many miles? Or sorry, 100 kilometers is how many miles? So let's do something with that. Kilometer. Okay. So kilo means 1,000. Right, so what this means is there is 1,000 meters in every 1 kilometer km. Okay, so I want you to think of, right, something that's slightly larger than a yardstick. 1,000 of those is what a kilometer is. Okay, so if we have 100 kilometers, or how many miles is that? Okay, we're going to have to use quite a bit of information that we have. And that's going to have to be a lot of with our customary system here. Okay. Now I don't really have anything here with metric, so we're just going to write the path here. We just wrote out we can get from kilometers to meters, right? 1 kilometer to 1,000 meters. Now what else can I do? I don't see meters anywhere here for length. So what else? Oh, but I do see centimeters. We just talked about earlier right, we have a conversion from, right, centimeters to meters, right? There's 100, I'll write it out. 100 centimeters in every 1 meter. Okay, so we're going real small here. So I took a big distance, made it to something close to a yard, and then I made something that's the width of a penny. Whoops, cm. Okay. Now I still got to figure out how can I get to miles. Okay. So I'm going to be using this right here. There is 2.54 centimeters in every 1 inch. Now think about an inch in terms of a ruler, right? That's still pretty small. But that's going to be the next thing we go to. All right, so let's look at the information that we have, and we're trying to determine some type of path. So like here to here, this is where I go from metric to, I'll say US, but there are 2 other countries that use metric system, Liberia and Myanmar. But those are 2 pretty small countries. Anyways, so we're now in inches. Now from inches, I can go to anything with inches where I can go a little bit bigger. We can go from inches to foot. Okay. So this is just setting up here. All right, how can I get closer to miles? I don't see anything from feet to miles, but I do see feet to yard. Whoops. All right. And then anything else from there? Oh, never mind. I made a mistake. I apologize for that. There is feet to miles right there. Okay. So I got rid of yard there, and I'm just going to put MI for miles. So we do have, there is 5,280 feet in every 1 mile. That is a big distance. Anyway, so these, what I highlighted, it's going to help us. I'll highlight the other ones that are also going to help us, which is right here and right here. Okay, this is going to be our biggest conversion yet. I'm going to say this. You won't have this many conversions on your assignment, but this is one that's going to definitely challenge us. Okay, so game plan is we're going to start with what we are given. What we are given is already underlined. We're starting with 100 kilometers. Okay, this is going to be over 1. We're going to set up a fraction that's equivalent, but we're able to cancel out kilometers. So that is right here, some conversion with meters and kilometers, 100 meters to 1 kilometer. Since kilometer is in the numerator, I'm going to put kilometer on the bottom. So 1 meter to 1,000 meters. Okay. All right, so we did this first one here. That's done. Now we got to do the second one, meters to centimeters. All right, meters to centimeters is right here. And how do we set that up? So we always set it up based on what's really at the top left unit. Because we know that our first unit is going to cancel out, right? So kilometers are going to cancel out. We're just going to be left with in terms of meters. This would be an excellent fraction if we wanted to know how many meters are in a kilometer, but that's not going to really help us for our problem. All right, so 100 centimeters with 1 meter. Since I have meters on the top left of that fraction, that means I'm going to put meters on the bottom of this right fraction. So we're going to put 1 meter. So that's that a little bit bigger than a yardstick, right? At the doorknob of a door. That is 100 centimeters. That's about 100 pennies. Just kind of lined up. That's that distance. So if you have something to help you just conceptualize that. Okay, let's keep going because from here, we're going to have meters that cancel out. Okay, but now we're looking at from meters, or sorry, centimeters to now inches here. What was that conversion that we have? Centimeters to inches. Okay, centimeters to inches was right here. That is 1 inch is equal to 2.54 centimeters. That's not a nice conversion because now we're switching systems here. Okay. All right, since I have centimeters on the top left, that means centimeters is going to go down here. But it was 2.54 centimeters is 1 inch. All right, we're getting there. We're getting there. We have 2 more conversions here. Okay, that means centimeters are gone. We've converted now from kilometers to inches. We still got to get to miles. Okay, so now we're going to, let's go purple. Inches to feet. All right, how many inches are in 1 foot? We know that, but you can use the chart here. Right, there are 12 inches for every 1 foot. All right, but the question remains, what goes where? All right, since we have inches on the top, that means we want inches on the bottom. Okay, and that means we'll have feet on the top here. We said 1 foot is 12 inches, so be careful with that. Right, I think many times we're probably just used to putting a 1 on the denominator, but in this case we have a 12. All right, and our final fraction here is going to be in terms of feet to miles. This is that big number there. Okay. Now this is half the battle. We can use a calculator to multiply this out. Okay, feet to miles or miles to feet. We have 1 mile is 5,280 feet. Okay. So since we have feet on the top, we'll put feet on the bottom. And that was 5,280 feet is 1 mile. Okay. Let's cross off this last unit. All right, this is just unit analysis on steroids. We won't do this like a ton. This is literally overkill, but I think it's good to still practice this. Now, with this, yes, we can use a calculator, but I would always strongly advocate that you try to use mental math before you ever get to a calculator. Let's simplify where we can. So an example could be, I mean, I see a lot of ones here, so that doesn't help me. But I see a decimal right there. I see some numbers that are like divisible by 2, or this last number that's divisible by 10. I mean, we can cut that down. Let's say 5,280, I'm going to cross that off. There's a common factor between that and, let's say 100. I'm going to cross off this 100 right here. They're both divisible by 10, so let's divide them both by 10. 100 becomes 10 here. 5,280, instead of a 4-digit number, it's a 3-digit number, so that's getting smaller. It's just 528, okay? Anything else that we can simplify? Let's say, or you're trying to figure out is there anything on the top of this thing also have a common factor with anything on the bottom? It could be something diagonal, it could be somewhere in a different fraction, same fraction, but you can't simplify on the same side, like the bottom with bottom or top with top. Anyways, let's use a calculator here, and then we'll figure it out from there. We can simplify after that. Okay. All right, we can actually do the numerator pretty, I think, simply there. So we have 100 times 1,000. The second fraction, which was 100 centimeters, just became 10. And then we have 1 times 1 times 1 mile. So that, if you multiply it out, just did it off to the side. Let's do, I'm going to put this over here because there's not enough room. That is 1 million miles. The denominator, we're going to multiply 1 times 1 times 1, which is nothing really. So we're just going to figure out what is 2.45, 2 and 54 hundredths times 12 times 528. Okay, we will get a, well, actually, will we get a decimal? Okay, times 12 times 200, or sorry, 528. All right, that is 16,094 and 44 hundredths. Let's divide these two numbers here. All right, all this to find out how many miles. All right. We are going to get a pretty big decimal, but we're going to say, we'll put equal sign. This is 62 points. We're going to round to the nearest tens place here. Or you know what? Let's say hundreds place. So 0 or 1, 4 miles. Okay. So to end this, put some closure on this here. We're just going to say 100. Oops. 100 kilometers is equal to 62 and 14 hundredths of a mile. Okay. All right. We're going to end it there, but thank you for your concentration and participation. We'll get some practice later, but for now, just make sure all of your assignments, previous assignments, are complete and you're working on Prodigy.